name is Cise, and I would like to use this opportunity to give a brief introduction into my background and my work and how it relates to UN Sustainable Development Goals. I have an undergraduate degree in civil engineering, followed by an MSc degree in concrete structures. I worked in the industry as a graduate structural engineer before I started my PhD at Lucy Cavendish College, followed by a postdoctoral experience at MIT. I started my academic career in Singapore and then joined the University of Glasgow as a reader in smart infrastructure materials, followed by Manchester this year as a professor of engineering net zero. Transitioning to a circular economy and achieving net zero targets by 2050 is a crucial commitment for the UK. This ambitious goal requires transformative changes across all industries, including the construction sector. I address the industry's heavy reliance on Portland cement, which accounts for 5 to 8% of global CO2 emissions. I create innovative and environmentally conscious solutions that target the question, how can we develop sustainable construction materials with high strength and durability and functionality? My work covers various sustainable development goals, namely number 9, number 11, number 12, and number 14. My work follows an interdisciplinary approach, incorporating various engineering properties with complementing capabilities, ranging from self-healing to CO2 sequestration to the use of waste materials in industrial byproducts and 3D printing technologies for rapid and efficient production. I can summarize my overall research in these 10 distinct areas. The first area focuses on the development of carbon neutral construction products involving the sequestration of waste CO2 generated by different industries within concrete products. The second area is on the sustainable production of cement from locally available waste materials. This involves waste resources such as reject brine obtained from desalination plants, as well as seawater. The third area focuses on the advancement of alternative binders with enhanced hydration and performance. The main goal here is to convert waste materials and industrial byproducts into powders that gain strength and perform in a similar way as normal binders. The fourth area focuses on the development of fiber-reinforced tensile strain hardening composites. The self-healing of these composites can take place without any human intervention, thereby enabling labor and cost-free maintenance of concrete structures. The fifth area focuses on the use of 3D printing for the production of sustainable construction components. The goal here is to provide housing options for people who have been displaced due to natural disasters and political conflicts throughout the production of these printed components. The sixth area focuses on the use of machine learning algorithms for performance analysis and prediction. This approach enables the accurate prediction of performance of different concrete mixes, thereby saving engineering costs, improving efficiency, and enhancing the sustainability of cement-based building materials. The seventh area focuses on the durability assessment of alternative binders with different reinforcement. We study corrosion resistance of reinforcing steel within sustainable composites under different conditions. The eighth area focuses on the recycling and reuse of construction materials. One of the overall goals of my work is to develop resource-efficient and net zero concrete as a part of the circular economy. To achieve this, we develop sustainable methods of recycling and reusing the construction and demolition waste and other waste generated by the foundation industries. The ninth area focuses on life cycle assessment. Here I verify the environmental benefits of these products via the assessment of their impact on human health, ecosystem, and resources, and provide recommendations on enhancing their sustainability. And the 10th area focuses on the transformation of vacant and derelict lands into usable spaces. Here we use waste CO2 obtained from the manufacturing industry, as well as CO2 generated by the microorganisms present in the soil to convert the contaminated vacant and derelict lands into usable spaces by local communities. In summary, my research targets the urgent challenge of achieving net zero targets in the construction industry. I do so by pioneering collaborations amongst diverse stakeholders along the supply chain, developing sustainable and functional building products using waste materials, providing solutions for material efficiency and circular economy implementation within the construction industry. All this paves the way for a sustainable future. And of course, none of this work would have been possible without my research team, as well as my collaborators all around the world, with whom it's an absolute pleasure to work on these exciting topics. Thank you very much for your time and attention.